An alternating EMF is applied to purely capacitive circuit. The phase relation between EMF and current flowing in the circuit is. Options are given. For a purely capacitive circuit, we can write EMF E equal to E0 sin omega t and current I equal to I0 sin omega t plus pi by 2. That is, current is ahead by pi by 2. So, option B is the correct one. A capacitor is a perfect insulator for. Options are alternating currents, direct currents, both AC and DC, none of these. Answer is option B, direct currents. For a high frequency, a capacitor offers. Options are more reactance, less reactance, zero reactance, infinity reactance. Capacitive reactance, we can write it as Xc equal to 1 by C omega. 1 by C into omega is 2 pi F. That means when F increases, capacitive reactance decreases. So, answer is B, less reactance. An alternating voltage E equal to 200 root 2 sin omega t is connected to a 1 microfarad capacitor through an AC emitter. The reading of emitter shall be. Reading of ammeter measures current. So it is IRMS, that is equal to VRMS divided by XC, capacitive reactance. VRMS is V0 by root 2 and XC is 1 by C omega. We can write it as V0 divided by root 2 and C omega will go to the numerator, C omega. That is V0 is given, that is 200 root 2 divided by root 2 into C is 1 microfarad. Micro is 10 raised to minus 6 and omega is 100. Sin omega t, omega is 100. So you will get 20 milliampere. Option B is the correct one. The frequency for which a 5 microfarad capacitor has a reactance of 1 by 1000 ohms is given by. We know the equation. Capacitive reactance is 1 by C omega or 1 by 2 pi C into 2 pi F. We can substitute the value 1 by 1000 equal to 1 by C is 5 micro. That is 10 raised to minus 6 into 2 pi F. We can find out F. We can take it to the other side. F equal to 1000 will go to the right. That is 1000 divided by 5 into 2, 10. 10 into 10 raised to minus 6 is 10 raised to minus 5 into 5 is there. So when 10 raised to minus 5 go to the numerator, it is plus 5 and here 10 raised to 3 is there. So 10 raised to 8 divided by 5. 10 raised to 8 we can write it as 10 square into 10 raised to 6 divided by 5, or we can write it as 10 square 10 raised to 6 is mega. So answer is 10 square or 100 divided by 5 megahertz. Option A is the. A 30 microfarad capacitor is connected to 150 volt 60 Hz AC supply. RMS value of current in the circuit is. RMS value of current equation is IRMS equal to VRMS divided by XC, capacitive reactance, because capacitor is there in the circuit. So VRMS given is 150 divided by XC. We should find out XC is 1 by C omega or 1 by C into 2 pi F. That is 1 by C value is 30 into 10 raised to minus 6, since it is micro, into 2 into 5 into F is given 60 Hz. So when you calculate this one, you will get 88.46 ohm. Substitute this value of 88.46 46, you will get 1.7 ampere. So option B is the correct one. In a pure capacitive circuit, if the frequency of AC source is doubled, then its capacitive reactance will be. Equation for capacitive reactance is 1 by 2 pi Fc. Here F becomes doubled, that is 2F into C. We can take this 2 here, so we will get 1 by 2 pi Fc. That means capacitive reactance becomes half. So option C is the correct one. An inductive circuit contains a resistance of 10 ohm and an inductance of 2 Henry. If an AC voltage of 120 volt and frequency 60 Hz is applied to the circuit, the current in the circuit will be. Equation for current is voltage divided by impedance. Since both the resistance and inductance are there, we can calculate impedance are square root of R square plus XL square, or square root of R square plus XL is L omega whole square, or square root of R square plus L into omega is 2 pi F whole square. That is, R is given 10 ohm, 10 square plus L is given 2 Henry into 2 pi F. F is given 60 Hertz whole square. So when you calculate this, you will get 753.7. So you can substitute this value into this one. Voltage is given as 120 volt divided by Z 753.7. So you will get the answer as 0.159 ampere, or approximately 0.16 ampere. So option B is the correct one. A 12 ohm resistor and a 0.21 Henry inductor are connected in series to a AC source operating at 20 volt 50 cycles per second. The phase angle between the currents and the source voltage is phase angle phi. The relation between phase angle and R and L are tan phi equal to L omega divided by R. So phi is tan inverse L omega divided by R, or tan inverse L is given 0.21, omega is 2 pi F, 2 pi into F is given 50 divided by R is given 12 ohm. When you calculate, you will get tan inverse 5.5, and this value 5.5, it is 80 degree. So option C is the correct one. And I have given the reference for tan for different angles also. From this, definitely 5.5 is greater than this 1.7, that is greater than 60 degree. So option C is the correct one. An alternating voltage is connected in series with a resistance R and an inductance L. If the potential drop across the resistance is 200 volt and across the inductance is 150 volt, then the applied voltage we can write it as square root of VR square plus VL square, since resistor and inductance are there. So it is square root of 200 square plus 150 square. So you will get 250 volt. So answer option B is the correct one.